Okay, I want to introduce the tidyverse. The tidyverse is an important set of packages that we will make use of. Arvest, I introduced Arvest earlier. Arvest is actually part of the tidyverse, and it makes use of tibbles and whatnot. So we'll introduce the tidyverse, and we'll introduce the tibbles data structure. So one recommended resource is this book, R for Data Science. You are able to read it for free in your browser. If you want, you can also purchase the textbook, from wherever you want. But the textbook is authored by Hadley Wickham, who is basically the creator of the tidyverse, as well as Garrett Goldman, who's also a good teacher on the subject. Okay. The tidyverse describes itself as an opinionated collection of R packages designed for data science. All of the packages share an underlying design philosophy, grammar, and data structure. These are the core packages that get loaded when you call library tidyverse. Now you can load any of these packages individually, such as dplyr or ggplot2. But you can also just load them all with tidyverse. You're probably already familiar with ggplot2, but or maybe not. But I will have a lecture on ggplot2 as well. We will look at tibbles in this video, and we'll also cover tidyr and dplyr. I've already covered readr, and later I will cover stringr. There's also per and forcats, which I don't know if I'll get to, but these are all very useful packages, and I highly recommend exploring them and reading the documentation for each of these packages. So the tidyverse, its central data structure is the tibble. It is very much like a data frame. In fact, tibbles are data frames, but they add a few tweaks so that they are more useful. Okay, R is an old language. It's been around for decades, and some of the things that made R useful, as far as kind of handling certain data types and the way it did things from memory, were useful 10 or 20 years ago, but now they kind of get in your way. And the kind of base R people are reluctant to making a whole bunch of changes, because when you do, it often breaks existing code, and so a lot of innovation is being done in packages, and kind of the caveat there is, when you load a package, you need to be prepared to update your code and things that have been around for a while. So that's what we have. Okay, so one thing is that tibbles have this print method, so that it only shows, say, around the first 10 rows, and fits and prints only kind of the columns that fit on the screen. And so this makes it a lot easier to kind of work with large data. And in addition to its name, each column reports its own type, kind of the data type. So, without having to call str the structure, you can kind of see the types of values that you have in there. So here we're going to just create a tibble called X. There's going to be 5 columns. The first column, A, will be just some kind of date time stuff. We'll have the date with some random number of days added. We'll have just some integers, some random values, and some character data. Okay, and this is kind of what it looks like. So the first thing is a date time object, and so we have the dates with some random times kind of here. We have random dates, we have integers, we have type double, we have type character, and you can see it just kind of prints out the first 10 rows, and it says 990 more rows, and it gives you information. It says a tibble, 1,000 rows by 5 columns, and it kind of gives you a quick little summary here. Okay. when you use a single square bracket with tibbles, one thing is that it will always return a tibble unless you explicitly use the drop argument. So, so here I have a simple tibble, 2 columns x and y, and here I subset to just the first column. I do from the tibble, just select the first column x, and it does this. Whereas, with a data frame, if you select something where it's just going to be kind of one column, a lot of times it will simplify it down to a vector. You can simplify a tibble down to a vector by calling, adding the argument drop equals true, but by default, using a single square bracket, it will always return a tibble there, okay? Here with a data frame, you can see when I subset the data frame to just the first column, it automatically simplifies to a vector, right? And that is different behavior for a tibble, okay? If you do want to extract the column as a vector, you can use double square brackets. That will extract it as a vector. You can also use $sign notation, and that will extract it as a vector. All right, so these are just things to be aware of regarding the behavior of a tibble. So the authors of the tidyverse and tibble said, hey, you know what? It's a little bit strange that when you use single square brackets, sometimes it reduces down to a vector, and sometimes it remains a data frame. And so here they've chosen that single square brackets will always return a data frame unless you specifically or explicitly ask for it to reduce the structure down to a vector. Okay, creating a tibble is pretty easy. You can just create it just like you would a data frame. You give it the column name equals, and then you put in the values, the vector of values that go into that column. Okay. Another thing is you can just take an existing data frame like empty cars and then just wrap it with tibble, right? Just throw tibble around it, and that will automatically convert the existing data frame into a tibble. You can also create a tibble row-wise so that a person reading your code can kind of have an easy time seeing the values in each row, and this is done by calling tribble. The R in tibble is for row-wise. So here's tib R. You name the first column, tilde column A, tilde column B. This is how you name the columns. And then what are the values? You put in character A and 1 for the first row, character B and 2, and character C and 3, and so on and so forth. And then when you do that, it creates a tibble, and it was drawn, row-wise. Okay, versus here you specify, the column A has this, column B has that, and column C has that. In order to kind of fit as many columns as possible, tibbles have a tendency to just display only one or two places after a decimal point. This is just in the display. It's not, it keeps all of the figures internally stored. It's just when it's being displayed, it rounds it, okay? So here I'm creating a tibble with just one row. Column A has the value 9.8765432. Column B has 1.1234567. And so when just kind of by default, in order to kind of keep the columns pretty narrow, it just rounds them and displays, only kind of like 3 significant figures, 2 places after the decimal, things like that. If you're like, I want to see all of them, you can specify that. You can specify options, and you can say, this is how many significant figures I want. Pillar.sigfig equals 5 will display 5 significant figures, so you get 9.8765, or here 1.1235. Again, internally, the values are there. It's not truncating or rounding the values internally. When you extract out the value, it will have all of the decimal places there. It's just for display to kind of keep things compact. This is what a tibble does. Okay, this sometimes students don't like this just because they're accustomed to the way R kind of displays like the whole number. But again, you're not losing any of the information. It's all there. It's just as far as being displayed, it's rounding it off. Okay. By default, when you ask a tibble to print, so here I took empty cars and I said make a tibble out of it, and when I print it, by default it only kind of prints the first 10 rows, all right? And it says 22 more rows, tibble is 32 by 11. That's the default nature. If you want to print more additional rows, you can do that. You just call print and you give it the argument n equals however many rows you want to print. So here, if I want to print all 32 rows, I'm going to say print empty cars tib, okay, which is the name of the tibble, and then I'm going to specify n equals 32. And so here we get all 32 rows printed out, and all of that information is there. It includes all of the information there. One thing is that you might notice is that there are no row names. So tibbles do not kind of use row names. So the empty cars data frame actually has row names. Each row kind of corresponds to the, I guess, the vehicle model, make and model. And tibbles don't discourage the use of row names as a way to store information. So if you want to kind of store data or values, it requires that you put it into a column rather than the row names. So when you print out a tibble, it doesn't include any row names. So so make sure you kind of, if you wanted to do something with empty cars, you should probably take all of the names from empty cars, the row names that is, and then make sure they go into a column, because otherwise that information is kind of lost. So so tibbles do not encourage or discourage the use of row names, and I would be in agreement with that kind of design choice. Okay. All right, so that's the introduction to tibbles, which we will see very frequently of because we will be working quite a bit with the tidyverse.